Now we're ready to actually maneuver, or to plan out the maneuver. Remember, relative motion is the vector sum of our true motion and their true motion. So if we want to change the relative motion, which is what we want to do, we want to bring the CPA away from us. We have to, for these two contacts, we want to get this direction of relative motion way out to here so it doesn't pass and hit us. That means we're changing the DRM, and we can't control their true motion, so we can only control our true motion. So we have to change our ER vector and see how that ER vector will impact the RM vector in the hopes that new RM vector will no longer be a threat to us. Ultimately, that RM vector will create a DRM that passes far enough away that we're happy with it. So we want a new world where the DRM of contact C passes around at most or at least 2 miles away from us. It never gets more than 2 miles, or it never gets less than 2 miles away from us. And we know that we're going to maneuver at M3. So this new DRM is going to start at M3 because the old DRM is going to be true all the way until then, but then we're going to change course and it's going to maneuver. Realistically, how you do this is you draw a line tangent to the outer limits of our CPA that we want. So if we want it to be 2 miles, we draw a line that is tangent to the 2 mile ring from the M3 mark, like so. Thing is, you could do that twice. You could do it over here, or you could do it over there. Both of them work. Both of them are contact C being more at least 2 miles away from you, giving you a 2 mile CPA so that you're nice and clear and avoiding risk of collision. So how do you pick which one you do? Well, remember the rules of the road. This is its projected relative position were it to take either of these two paths. On this projected path, if this is us, it shows it facing this way, passing astern of us, like so. On this projected path, it shows it facing this way, passing ahead of us, like so. We are the giveaway vessel. We cannot pass ahead of them, meaning they cannot be allowed to pass astern of us. We have to use this path because this is the path where it continues on its course and speed and remains ahead of us, thereby we gave way to it. So we have to choose. You always have two options for the DRM. We have to choose the one that actually conforms to the rules of the road, and in that case, it's this one. It's usually the one closer to your heading line because that's where it's going to be passing ahead of you. Usually the one astern of you is not going to be relevant, but you have to visualize that and know which of the two options you use. So we're going to use this DRM as our new DRM. What that means is we're going to superimpose that new RM vector onto our original vector triangle for contact C. And remember, this is now R to M, just like this is R to M. And it's going this direction. So just like when we plotted ER here, where we went the opposite direction of our true heading, so we could plot the E before it so it points this way, we're going to have to draw out the DRM here going the opposite direction that it goes so that we could place the new R somewhere up there to bring us back to the correct direction. So there's my triangle. So we set our triangle to be in line with our new DRM, and we slide the triangle up until it passes over the M mark in our vector triangle. And we draw it up like that. It's okay if it goes off of the scope, it's not important. So R is now going to land somewhere. For this line to be the R to M line, R has to land somewhere along it. Somewhere. We don't know exactly where yet, but it's going to land somewhere along that line. Where it lands depends on how large the ER vector is. Technically, if R were to land anywhere along this line, it would give us a DRM along this course, which would give us a CPA that passes 2 miles ahead of us. However, if it were to land here, wherever it lands, we would then have to connect E to R, and that would be our new course and speed. So if it were to land here, we would have E to R here, and whatever its new speed would be whatever this distance is. If it were to land all the way up here, then E to R would be all the way over here, but its new speed would be whatever that distance is. So whatever we have to pick based on what we want our speed to be as well as our course. Well, the rules state you should probably just stick to, this is not the exact wording they use, but you should stick to just a change in course and not affect your speed. So we want our speed to stay the same, meaning the length of our ER vector should stay the same. This is part of why it's really helpful to have a compass and why it's frustrating that I don't. But if we were to measure out this distance, using a compass, you could then just swing this arc all the way around, like so, and that would instantly show you where your ER vector should intersect the RM vector. Pricking it is kind of working, but realistically they passed through here. We're going to label this R prime. And if we connect the dots there, that would be a new course that we could head based on the same speed. We're still going 15 knots between these two courses, but if we were to go on this course, it would cause the RM vector to look like this. And that RM vector would give us a DRM that looks like this for contact C. So we got to measure out what that true course is. And we get slipped a little bit. We get 293. Mark that. We got 293 as our new course to follow. So in other words, they're headed this way. We're headed this way. We will change course to 293, and that will allow them to pass ahead of us. Now, realistically, when you change course for a contact, you should change course enough that you're passing behind it automatically. That way they can clearly see you, and they know that it's an early and substantial change as per the rules because you're not even pointing ahead of them anymore. However, coming to 293 will allow them to pass ahead of you at 2 miles. Going further than that will mean they pass ahead of you more. It's technically better according to the rules, but this is what your captain told you to do. So 2 miles is where you're going to stick with it. Now, however, you need to see how this is going to affect your other contacts. So what we're going to do is we're going to now carry over this new ER vector, and we're going to apply it to the other vector triangles and see what that does. So if we measure out the angle of ER prime for contact C, we can then slide it over. Oh crap! I have to move you again. We slide it all the way over to contact B, because they're kind of our next priority. I'm just going to draw it out and tell you what I did later. Okay. Sorry, it was really difficult to fit. However, we brought the ER prime from up here, slid it all the way down to here, and drew it there. Remember, we're not carrying over the RM vector like we did with this. We're carrying over the ER vector because that's what we care about. We don't know what the RM vector is going to be for contact B. We're determining it now. So we drew it out in the opposite direction of our ER because it's going to be E2R. So now we have to measure the distance. So we take the distance. It's still 15 knots, which should be exactly the same as our ER we had here. It's essentially the same, still 15 knots. And we draw it like, oh wait, I'm stupid, sorry. I shouldn't have put this on the R. I don't know why I did that. Should have put it on the E because we're making a new R. E stays the same because EM has to stay the same. So we slide this up to E. We draw it like that. So this is not correct, it's that. And it is going the same direction because it's still E2R. So we measure out 15, like we did, and we draw it here. And that will be our new R prime for contact B. In the original triangle, we had ER this way and EM that way, which created an RM of that. But now we have ER this way, and you can see EM is still, of course, that direction because that didn't change. And so now we could say, measure out what the RM vector for contact B will be. Connect the dots. See the RM line is really small here for the new RM. And now that we've gotten that angle, we can slide it up to M3 and continue it. We know we're going from R to M, so it goes out this way. And you can see if we maneuver to 293 for contact C, it will pass ahead of us at 2 miles, and contact B will swing way all the way out to here. So that will definitely pass clear of both of them, and we will pass astern of contact C, and we will definitely give way to contact B. So this maneuver will work well for contact B. It's maneuvering for C, but it works with B. So now let's see how it works with A. So we're going to take our same ER line, ER prime line that we got, and now we're going to slide it over to contact A and see how it impacts things there. So remember, we're going to connect this to E. We slide it up to E. We draw it out like that. And then we take the ER necessary from contact, from all of them, because this is the ER line that's been true throughout, worth 15 knots, and we bring it up to there. And that gives us a new R prime. So that's the R prime now. We're going to connect that to our M, which is right there, like that. Connect the dots between the two. We get an angle like that. And now we're going to slide that over to to M3 and see how that affects things. Okay. You can see if we use this RM line, starting at M3, it actually causes contact A to also have a larger CPA. Now, A wasn't a concern. It was already out to 2.8 miles. So coming out further to more than 3 miles, that's good. That's not a problem. The only concern would have been if it were to come in towards us more. If this maneuver were to cause the CPA to close in towards us, then it would be a concern. But that's not happening yet. So we're fine. This maneuver of 293 will pass clear of all contacts in accordance with the rules.